Hey folks, in this lecture we are going to review arrays, which are data structures that allow you to hold many things that are of the same data type. So you guys probably dealt with arrays in 1321 or possibly 1300. But we're just going to do a quick review of how you use an array, what it's for, and a couple of quick examples of how you might go about working with an array. So again, the first thing about an array is that it is a structure that holds lots of the same type of data. That type of data can be an integer, it can be a car, it can be a string, or it can be an object that you've created. So if you've created an object called a dog, you might have an array of dogs, and each dog would be, Fluffy and Grizzly and all of your other dogs. So each one of the dogs and each one of the items that are in the array, they must be of the same data type. That is one requirement. So you can have an array of ints, but you can't then stick a letter B into the middle of the array of ints. They have to all be integers because you declare them that way. So the declaration of how you declare a array is pretty simple. You're just going to say the type, and then you're going to have square brackets to indicate that it's an array. Inside those square brackets, on the second time that you do it, you're going to specify how big the array is. And you can see what I'm talking about here if I can get my marker to work. There we go. All right, so in this case, we're doing trophy, which is some kind of object that we've declared previously. So we're doing a trophy array. We're calling it trophy or troph. Pretty sure that's meant to be something else, but anyway, troph gets new trophy of size 10. So you're always going to have the data type with the square brackets at one end, and you're going to have a new call on the other end because you are creating a new array. You're having to actually occupy some memory. And when you do the new call, you have to specify how big that amount of memory is. So in this case, it is maximum size of 10 cells. So it can hold from 0 through 9 is what this would do. And each one of those cells can hold one trophy. All right. You can't use it until you do this. You can do these two statements separately, which is what's happening up here. One is declaring that we're going to do it, and then the second one is actually creating it. But until you do this second line, it doesn't work. You can't then, after just doing that, you can't start assigning things to it. You will get an error. The exact syntax of where you put these changes from C# to Java, and that's just ever so slightly annoying. So let's just jump out and do an example ourselves here in Replit. So this is the Java example, and what I did was I created a new array. It is of type integer, and I went ahead and initialized it with some values. All right, so let me be clear. There's no reason that you have to do this. I could have absolutely done something like this. So again, you can break these up into multiple statements. This is all the same code as what's written down below. I can say int my array, and then I can say my array equals new int, and then I can say my array at position 0 equals 1, my array at position 1 equals 2, my array at position 2 equals 5, and so on and so forth. Where am I getting these numbers from? Well, they're coming from just down below here. What I did by putting these curly braces at the end of the declaration is that I set it all at once. I simply made it so that there are 10 cells because I put 10 numbers in here, and I specified what each of those numbers would be. So the first cell held a 1, the second cell held a 2, and a 5. So this is just a shortcut to doing this, because that's kind of ugly, quite frankly. But it definitely works, and they're both completely valid. There is many times if you're only initializing 2 or 3 items in the array, you would typically do it this way. If you're trying to stick a whole bunch of stuff into an array at once, you might do it this way, but it's also very hard to read this way if it's a big long list, so maybe the other way is better. So it just depends on what you're trying to do. Okay, so yeah, if we're going to do it this way, you actually do have to specify the size. So let me explain this. Down here, when I did the int, new int, I didn't specify a size, and that's because it knows how big it is based on how many items I put in the curly braces. As a matter of fact, if you try to put a number in there, the compiler kicks it back and says, you can't do that. You can't tell me how big it is and then give me the values. It has to figure out the size by itself if you give it values. But if you're not doing that, then you must specify a size. And so up here, I'm going to put a 10 in there, and that's, what have I done? That is going to give me the same thing. So to be clear, this code up here is the same as the code down below, well, at least for the first 3 cells. It's just that they are 2 different ways of writing the definition of an array. If I flip over to the C# version of this, you will see that there is one thing that's ever so slightly different. I'm just going to go back and forth. In Java, you say int, and then you give it a name and you put the square brackets after the name. In C#, you say int square brackets and then give it a name. You will see me typo this many times. Beyond that, it's the exact same, but where you put the square brackets changes. In C#, you put it right after the type. In Java, you put it after the variable name. Okay, so those are the difference in initializing it. Okay, so regardless of however you get the data in there, the next question is, and actually I should leave those in there so that you guys have access to them in case you want to look at it 2 ways. All right, I am going to comment this out because it will produce an error because I am using, what am I doing? I am using the same variable name. So it'll produce an error and say it's already defined, you can't do that. All right, so if I run this, it's going to create the array, and then this system.out.println line is going to print the value from the second cell of the array. The second cell of the array, this is cell number 0, that's cell number 1, so the second cell of the array is that 5, and so in theory, whenever this compiler gets done, you're going to see it spit out the number 5. This is how you index an array, or how you specifically address one particular cell of an array. You specify the array name, followed by square brackets, and then a number to represent what particular cell value you're trying to see. I totally would have said that I had hit run, but apparently I did not. All right, and indeed we get the number 5. And just to prove that things are the same on the other world, in C#, we should also get the number 5 because it's the same array in both cases. All right, so that's how you declare an array, and it's how you might access one cell in the array. Most of the times, if you're putting stuff in an array, there's a reason that you put it in an array, and that's because you're probably going to do something to it. So for the rest of this example, what we're going to do is we're going to do a couple of different things to the numbers that are in the array. So, for example, if I asked you how to figure out the smallest number in the array, how would you go about doing that? And before I do that, I'm just going to change a couple of the numbers in the array so that I don't have the same number repeated multiple times. I seem to have a lot of 2s. I'll make that one 22, and I'll make this one 12, and that one is 2. Okay, and I'm just going to copy that between the 2 windows so that life is good. All right. Okay, so how would I go about finding the smallest value in an array if I needed to do that for some strange reason? Well, the answer is you would start off by taking the array and you would walk through it using some form of a data structure. And the data structure, sorry, typing and talking not working today. You would use some form of a loop to go through the data structure and find your smallest value. So how would you go about doing that? Well, you'd start off with the array, like we have here, and then you would have some form of a loop. If you've watched the loop video, you know that you have a couple of choices here. You have a for loop and you have a while loop. And I'm also going to introduce to you in this video a for each loop, but we're going to start off with a for loop. So I'm going to say for, and I'm going to do int I equals 0, I less than 10, because I happen to know there are 10 things in here, I plus plus, so that's going to iterate through my 10. Now, as I'm going through all 10 of these cells, which to be clear, my array at position I is going to initially look in the first cell, and then it'll be in the second cell and the third cell. So what is it that I'm trying to do? Well, I'm trying to find the smallest item in the array. So how do I go about doing that? Well, one option is we might set smallest to the first cell, or arbitrarily, which ironically is the correct answer, but that's not important right now. Then as we're going through the array, as we're going through the loop, what we're going to do is we're going to compare each one of the cells with that first one. If any one of them is smaller, we're going to swap it out. So to be clear, I'm going to say if the array at position I is smaller than smallest, which is my variable that currently holds the smallest, then I'm going to make smallest equal to the current cell that I'm looking at. And at the very end of this, I'm going to print out smallest is, and the smallest, whatever value that happens to be. So that's going to run through my array. There are 10 cells in the array, so I'm going to go from 0 to 9. And as you can see, it successfully finds that the number 1 is the smallest value. Now you might be thinking, okay, but didn't you cheat? Because isn't the number 1 right at the very beginning? So just to make sure that I didn't cheat, let's make that 100, and let's make that one 200, and then let's run it again. And you will see that it still will figure out that 3 is the smallest, even though that's towards the end of the array. Okay, now why does that work? Because the for loop is going to start off at position 0, because that's where I told it to start. The for loop is going to keep going while I is less than 10, and it's going to add 1 to I each time. So the first time through the loop, it's going to be looking at position 0. It says if the array at position 0, which is 100, is less than smallest, which it is not, because 100 is not less than 100, so it's going to go back to the end of the loop, which brings it back up to the top, which causes I to increment. I is now equal to 1, because it was 0 a minute ago. So now we're going to go into the loop again. If the array at position 1, which is the number 200, is less than smallest, which it is not, because 200 is not less than 100, so it's going to come back up and go through the loop again. I is now equal to 3, so it's the value 5. If my I said I is equal to 3, it's actually equal to 2, sorry. So if my array at position 2, which is the number 5, is less than 100, which is the current value, which it is, then it's going to set smallest equal to 5. And then it's going to go back up and around the loop again. I is now equal to 3, and this time that's going to be the value 12 when it looks here. So is 12 less than 5? No, it's not. I is equal to 4, so now it's the number 10, and so on and so forth. And it's going to do this all the way through the loop. By the end of the loop, whichever one was the smallest one is going to have been captured in a variable called smallest. So that's a very common thing to need to do in a loop, is to go through it looking for something in particular. So in this case, we were looking for the smallest. What happens if I was looking for the largest? Well, you should code that. Take this code, fork it, and try doing the same thing, except this time look for the smallest. The pseudocode of that is you're going to assume that whatever's in the first cell is the largest, and then you're just going to go through and compare every cell to see if it is larger than the first cell. Now, a couple of things about this. I hard-coded the number 10 in here, and that's a little bit dangerous. It's perfectly valid because I know there are 10 items in this array. But just to show what would happen if I had been wrong, I'm going to set that to 12, and I'm going to run it again, and this same block of code is now suddenly going to crash. I get an exception in thread main, index array index out of bounds exception, index 10 out of bounds for length 10, which is all a bit confusing. But what happened here was this ran 10 times, like it was supposed to. It looked at cell 0, then cell 1, then cell 2, then cell 3, and it got all the way up to cell 9. But then it kept going, and it tried to access my array at position 10. When it tried to do that, that's when you got that error. And the reason is because there is no cell 10. Even though there are 10 things in the array, they are cells 0 through 9. So when I try to access cell 10, I'm going to get an error and the program is going to crash. So it's very important that you are correct about the length. Is there another option instead of typing in the number directly? Yes, there is. You can ask the array what its length is. And now that will work correctly. And even if I add a number into the array or add another cell in there, life will be good. It'll still work the correct amount. So I don't have to specifically remember that there were 10 in there and write that in correctly. So myArray.length is probably a better way to do that. Okay, so that gives us a check of how you would get the smallest or the largest. Let's go about calculating the average of all of those numbers. So we're going to do another loop. So let's this time do it with a while loop. So in this case, I'm going to need a variable that is my index, which tells me which cell of the array that I'm looking at. So I'm going to say int index equals 0. And then I'm going to say while index is less than myArray.length. All right, and now I'm going to go through and do a sum of all of the numbers. So I'm going to set sum equal to 0 before I start. That just creates me a variable. I'm going to say sum plus equals, so I'm going to add to the sum variable myArray at position index. So as it goes through the loop, it's simply going to add each one of the values of the array to my sum variable. If I now go down and I can say float average is going to be equal to the sum divided by myArray.length, because the length of the array is how many cells we have, which should be about 10. All right, and so float average, why is it not happy with that? Oh, because I never used it. Okay, fine, I will use it. System.out.println average is now. Picky compiler, are you happy? All right, so when we run that, it is still calculating the smallest, but then it's also going to calculate the average for me, and I should see whatever the average is. Yep, that is valid. I did not put a semicolon there. Okay. All right, so why is that sitting there? Okay. I can tell you why that's sitting there. It's running forever and ever and ever. Now, bonus points, which don't count in any test or any valid thing, but bonus points to anybody who can tell me what I did wrong. Well, the problem is that I checked to see is index less than the array length, but at no point did I ever change the index. So if you look at this code, index is always going to be 0. So it's continuously adding the number that is in cell 0, which is 100, to sum. So if I could magically look in there right now and see what's going on, I would see that sum is equal to some massive number. So what did I forget to do? I forgot to change index. So if I simply say index plus plus in there, that should fix the problem, and I should now actually get the answer. There you go, average is 37. I'm going to take its word for it because I don't feel like doing the math. All right, so what you're going to find is anytime you're processing something in an array, you are most likely going to use a loop. Honestly, most of the time you're going to use a for loop or a for each loop, which is the next thing that I'm going to talk about, but it is possible to do it with a while loop. You just have to keep up with the variable yourself. If you think about it, what I did down here is really the same as a for loop. I just broke it up in a couple of different places. So this part here is really equivalent to this initialization. This part here is really equivalent to my test. And this part here, which I forgot, is equivalent to that. So really, there's not much difference between the for loop implementation and the while loop implementation. It's also possible to do this with a do loop. You just have to move things around a little bit. All right, so I'm going to do one more thing, which is I'm going to show you how you would do this using a for each loop, which is the other type of structure that we have for looping. All right, so again, we're still in Java. I'm going to come back and show you the C# version of all of this code in just a second. So in Java, a for each loop is going to be done with the for word. Ugh. My computer has decided to go offline again. I'm going to pause and fix that one moment. There we go. Okay, so we're going to use the for word. We're going to use the word for. So in this case, the syntax is ever so slightly different. Let me explain what a for each loop is. A for each loop is used predominantly when you are working with an array or some form of collection. There are other forms of collections like array lists and some other things that we're going to see later on in the class. But for right now, the collection that you know about is an array. So a for each loop allows you to automatically iterate through the array without having to keep track of the indexes and all of that. So what I'm going to do is I'm going to say for int, we're going to say cell, and then we're going to do colon, and then we're going to do the array number, or the array name, which is my array. And then we're going to have our curly braces just like we do in any other loop. So I'm going to just count how many items we have in here, which I realize is completely silly because, of course, I could just do my array.length, but just so that we're doing something. So, excuse me, sorry. In case you're wondering why I'm seeing random characters sometimes, I'm using VI as my editor, and so those are commands to VI. Anyway, all right, int count equals 0, and then down in here, I'm going to say count plus plus, which this is a really terrible example. Okay, let's not do this. let's try and find the largest item in the array. So we're going to say largest is equal to my array at position 0. All right. So if cell, which is going to be one of the cells, is greater than largest, then largest equals cell. I don't think it's happy with the word cell. It seems like it's okay with it. Okay, so down here we're going to do another print statement. And we're going to say largest and this time we're going to remember to put the semicolon. Okay, so let's explain what's going on here. In a for each loop, what it's going to do is it's going to take the array and it is going to, one at a time, assign each cell to whatever variable you put before this colon. So it took, in this case, the number 100, because that's the first cell, and it's an int. This has to match the type of the array. It set cell equal to 100. And then if 100 is greater than largest, it does whatever it's supposed to do. The second time through the loop, it's going to change cell to be equal to the second value, which in this case was 200, and then we go through the loop again. So it automates pulling in all the items out of the array for you and just allowing you to say, for each cell in the array, do this. That's kind of how you would read this. As a matter of fact, the C# language uses the word in, so it literally reads that. You say, for each cell in array is how you do it in C#. It actually reads as if it's English. Java is a little bit more goofy. It's for cell : array, because that makes sense. But anyway, so a for each loop is a very handy tool to have in your tool belt because it allows you to not have to write the management of now look at cell 0, now look at cell 1, now look at cell 2. Note, I don't have to care how big the array is. I don't have to care anything about it other than I have to know what type each of the cells are, and then the for each loop does all the magic for me. It just gives me a variable that each time through the loop is automatically set to the next thing in the cell, in the array. For each loops work not only for arrays, they also work for array lists, and for most of the other data structures that we're going to see later on that are collections. So I'm going to pause again and I'm going to convert all this code over to C# and then I'm going to come back to you. Okay, so here we are in the C# window. You can see the URL up on top, and let me just tell you what I changed in order to make this work. I copied and pasted the same code over, and the only things that I changed here were I had to move those square brackets. They were formerly here, they're now here, because that's how you define arrays in C#. I had to change the capitalization of the word length. It's a capital L when you're accessing the length of an array in C#. So it's myArray.length with capital L. That happened in a couple of places. Obviously, the system.out.printlines became console.writelines. And then the last part was what I had alluded to, a for each loop, where I said for each int cell in my array, as opposed to for int cell : array, which was the Java version. So that gives you all of the changes, and this, as you can see on the right-hand side, works exactly the same, and you get the same outputs as you do in Java. Said he, checking to make sure that they're the same. They are. Good. All right, so that explains 1D arrays. And so I'm just going to flip through these slides just so that you can see that we've covered all the same things. Arrays can be of any type. In this example on the slides, they are of a type that is a class, but they can absolutely be a primitive type, just like I did here. Traversing, this is the for loops, and this is the syntax for C#. This is the syntax for Java. This is the capitalization of the word length. You'll notice that we're pretty much always doing a loop. This is an example that's showing you how to find the minimum value, and an example showing you how to find the average. There's nothing magical going on in any of that. Okay, so the last topic that I'd like to talk about, which isn't directly in the slides, is that arrays can be multidimensional. Now, what does that mean? So this array was a singular dimensional array, meaning that it only was in one line. But it's possible, and it's actually quite common, that you will sometimes want to have a grid of cells. And the reason that that might be helpful, there's a number of examples, but if you do anything with math matrices, if you remember doing that when you're in, I guess, Algebra 2, you probably did like matrix multiplication and matrix addition and stuff like that, and you'll remember that it's a bunch of numbers that are laid out in a grid. So that's one example where a two-dimensional matrix will be helpful, or sorry, a two-dimensional array. Another example is if you have some kind of a game board. So if you think of chess, if you've been watching Queen's Gambit on Netflix or whatever, so if you look at a chessboard, it's 8 cells across by 8 cells down. And so a chessboard is 64 squares, but it's 8 rows and 8 columns. And that, again, could be represented as a two-dimensional array. Now, why might you want to do that? Well, you might be writing a program where you're keeping track of where all the pieces are. And so you might assign each piece a different number, like the king might be number 100 and the queen might be 50 and the rooks might be 20 and so on and so forth. And then you can keep track of where they all are on a board using a two-dimensional array. So there's lots of applications for two-dimensional. It is even possible to have a three-dimensional array, which is the same thing as a grid, except now it also has a third dimension so that you have a depth in there. And so if you're thinking of something like a cube or some structure like that, then each one of the cells would be in a 3D array. Think of like a Rubik's Cube if you can think back to when those were very popular. So that's effectively a 3D array because you have depth as well as width and breadth. Any kind of box is a 3D array. So, and again, you might want to store information in there. Okay, so cool. How do you go about doing that? Which language am I in? I'm in Java. Awesome. All right, so a two-dimensional array in Java is defined as, we'll call it my 2D array. And I'm going to say gets new int, and in this case, we're going to say 10 and then 10. Okay, so that's the first thing that's different syntax-wise. Instead of just having one set of brackets up here, I'm actually going to have 2 sets of brackets because I am defining a two-dimensional array. When I bring this guy over to C#, there's supposed to be 2 brackets on both sides, not just one. There we go. When we bring this over to C#, the syntax is going to be ever so slightly different again, because C# likes to do things differently. So I'm going to paste this into the C# window, and then I'm going to fix it. What have I done? What have I done? Okay. I clearly did not copy, is what I have done. Copy. Okay. The syntax difference, of course, is we're going to have these square brackets here, but we also don't use the same square brackets. We do it like this. And likewise over here, instead of having 2 square brackets, it's done like that. So in C#, you are going to have a comma inside of the square brackets to indicate that there's a second dimension, and you're going to list the sizes as 10, 10, whereas in Java, you're going to list the sizes as square bracket 10, square bracket 10. All right, so if I wanted to put something into one of those cells, I might say my 2D array at position 0, 0 equals 17. And then I might want to say my 2D array at position 5, 0 equals 22, and my 2D array at position 9, 9 is equal to 100. Okay, the equivalent of, so hopefully that makes sense to you guys. The equivalent of that over in the C# window is very similar, but ever so slightly different. We're just going to remove the inners and put a comma instead, just like that. Okay, and so that assigns individual cells with particular values. And then, of course, I can do all the same things that I could do before. If I wanted to print out or set all of the values in a two-dimensional array, I would usually use 2 loops, and those loops would typically be nested. So I'm going to go ahead and I'm going to set all cells in this array to the number 0. So I'm going to say for int I equals 0, I less than 10, I++, that's a pretty standard for loop. If that's confusing to you, then you might want to go back and look at the loops lecture. And then inside of there, I'm going to say for int j equals 0, j less than 10, j++. And just to make this a little bit clearer, I'm going to actually name these a little bit better than I did before. So instead of calling them I and j, I'm going to call the outer one row, and I'm going to call the inner one column. Now, why do I have a need for 2 loops? Okay, so that will set all 100 cells of the array to 0. Now, again, why do I need two loops and why is one of them inside the other one? What are you doing? This is making my head hurt. Okay, so the outer one is going to iterate over the rows. So let's think about this for a moment. And what I'm going to do is I'm just going to draw a much smaller version of this array. So we're going to assume that it has 3 cells and 3 rows. So this is 0, that's 1, and that's 2. That's 0, 1, and 2. So if I want to access, not that cell. That is not the eraser. That is the eraser. Okay, so if I want to access this cell, what is the correct address of that cell? We're assuming this is called my array. That cell is going to be cell number 1 because I type in the row first, and then cell 2 because I type in the column second. Okay, so the address of that cell that I put an X in is 1, 2. All right, so what my for loop did is that, and I'm just going to draw that same exact thing here, 0, 1, 2, 0, 1, 2. I did a for, and then I did row equals 0, row less than 3 in this case, row plus plus. Okay, so that loop by itself is going to initially start off at 0, and then it's going to do everything that it needs to do inside of the loop, just like a for loop always does. So this outer loop will initially be 0, which refers to this row, only because I said it does, and then it's going to do everything between the curly braces. So what do I want to do inside the curly braces? Well, I'm going to say for column equals 0, that's an equals, column less than 3, column plus plus, run out of room. But anyway, and then there's another set of curly braces. So what's going to happen in here is this inner loop is going to start at 0, then go to 1, then go to 2, and then it's going to exit. So when I say my array at position row column, hopefully you can see that it'll start off with the row equal to 0, and then when it comes to this inner loop, the inner loop is going to set column equal to 0, and then row equals 0 still, but column is now 1, and then row equals 0, but column is now 2, and then this inner loop is going to exit because it has done what it's supposed to do. At that point, we're going to go to the bottom, and that's going to bring us back up to the top of the outer loop, which is going to set row equal to 1. We're now going to go back in, and that's going to cause the inner loop to happen all over again. So we're going to do 1, 0, 1, 1, and 1, 2, and now the inner loop is done. We're going to go back up to the outer loop, set that to 2, go back to the inner loop, and the inner loop is going to happen all over again. So one way that I want you to think about this is that the inner loop will happen every time the outer loop happens. And the inner loop is going through the columns, the outer loop is going through the rows. Now, just because I call this row and I call this column, that's not what makes this deal with the rows and this deal with the columns. The reason that that's happening the way that it is because of the way that I wrote the array reference. I could have said column here and row here, and that would have done the opposite of what I just did. So the name is not meaningful. I need you to understand that. It's just the placement. The outer one I'm using in the first cell, and the first cell references the row number. I can call it Bob, and it'll still do the same thing. I need you to be clear about that. The second one, the inner one, I'm using in the second space, and that references the column number, and therefore I'm going to iterate through all of this. You could absolutely do it the other way. You could do the outer one dealing with the columns and the inner one dealing with the rows. You could do anything you wanted as long as you get through all of it. So this is what you're always going to write if you have a 2D array. If you have a 3D array, you're going to have a loop inside a loop inside a loop. And the inner one is going to go through the Z dimension effectively, whereas the middle one's going to go through the Y dimension and the outer one's going to go through the X dimension, or whatever it is that you decide you wanted to do. But it is important to understand that you need a loop in a loop when you're dealing with two-dimensional arrays. All right, and so everything that I did here, I'm just going to copy that over to the C# window. Actually, nothing is going to change in the C# window except for the comma down at the bottom. That was not copied. All right, so over here in the C# window, we're just going to paste that, or not. There we go. And so all that's exactly the same, except for C# uses that comma instead of that inner one, and that should still set all of the cells to 0. If you were going to go through the array and look for the smallest value, you would do it the same way you would need the 2 loops. Anything that you're doing with a 2D array is almost certainly going to require 2 loops, one of them inside the other loop. So I hope that makes sense to you guys, and that is today's lecture with regard to arrays, and I hope that that all made sense and you guys are fully caught up. Of course, the 2D arrays can be of anything. They don't have to be integers. They can be characters or they can be objects, and you absolutely can use a for each loop on a 2D array. You just have to be careful about that, because what you're going to do is the outer one is going to be a for each loop on the array, and that's going to give you an array, and then the inner one is going to be a for each loop on that array that you got from the outer loop. So the syntax of that's going to be just a little goofy, but it is absolutely possible, and you can certainly do a search on that. All right, so that is the end of the arrays recap. Hope you guys are doing well.